In this video, I'm going to talk about stack memory and heap memory. Remember this toy from your childhood? How do you take out the yellow ring from this? You'll first take out the blue ring and then you'll take out the green ring. Only then will you be able to pull the yellow ring out. This is sort of like a last in, first out, which means the last one that comes in is the first one to go out. So this is called stack approach, and it follow last in first out approach, LIFO. Java follows the similar methodology to allocate memory while we run the program. So we'll have a stack and it will have sections in it. Each of this section will be dedicated to one particular thread. You can think of thread as a single process, very small process. Or you can think of it in this manner. Let's say I created an object and I say object.m1. I call method m1. Now a section will be dedicated for that method in this stack. So let's see how it's done. Let's get into the internals. Now take a look at this. The execution starts from the main method, and main being a method, a section in the stack will be dedicated for it, for main. Java Virtual Machine uses this section to store all the variables that are local to the main method. In this case, x and y are the local variables that are local to the main method, and these variables will have the scope within that method. Whatever are the variables that have the scope within this method will be residing here. In this case, it's x, just 10, and y, 20. And the interpreter goes line by line. We'll talk about this line pretty soon. When the interpreter comes across with this line, object.m1, we're calling another method. So another section will be dedicated in the stack for method m1. And whatever are the variables that have the scope of m1 will be residing here. In this case, we're sending one parameter x. So we're taking it as parameter p, and the value of that would be 10, because that's what we're sending here. Interpreter enters inside this method and it starts executing lines in it. This is supposed to be m3. When the interpreter comes across with m3, we're calling the method m3. And since this is another method, a section will be dedicated for it to store its local variables, and local variables will be residing here. And once interpreter comes to the last line of method m3, it goes back to method m2 and it will continue with execution of further instructions in the method m1. Now at this point, since we're done with m3 method, even the memory will be freed and is available for future processing. Once the interpreter comes to the last line of method m1, it will go back to the main method and it will execute the remaining instructions. Once it returns back to main method, even m1 method will get freed, and whatever are the variables that are inside this will be lost as well, because we're done with operations that needs to be performed on those variables. Now once we reach the end of main method, even this memory will get freed. When we have nothing in the stack, that means we're done with the execution of the program. Now let's talk about this particular instruction. We have a heap memory as well, in that we'll store objects, and each and every object will have a location, an address associated with it. This address in here is used to locate that particular object. Let's get into the details. Let me go to a fresh page. Now take a look at this. We have a new keyword used. This particular section in this instruction will create an object in the heap memory. And take a note that we're passing some parameters to the constructor of the maths class 10 and 20, and we're setting the instance variables. And these two variables are instance variables, and they're not local to any method. They are specific to an instance. Hence, this will be stored in here. Maybe A is equal to 10, B equals 20. And in order to identify this object, there will be an address associated with it. Let's assume it's 0101. Now do take a note that the obj in here doesn't hold the object itself. It will hold the reference of that object. Let me explain you what I mean. Let's assume that this is inside a main method. So we'll have a stack created and a section will be dedicated for main method. Now we'll have this obj created in here. And what's the value in it? The value of it would be 0101, which is the address where this particular object is residing. So this is also called as a reference type because it will have information on where the object is residing. But this obj doesn't hold the object by itself. It will just have some information about where the object is residing. And the scope of this obj is also within this main method. Once this particular section pops out of the stack, then the reference of this object is no longer available. In our stack memory, we store the primitive data types as well as the reference type. You can hear terms like reference type, non-primitive data type, or user-defined data type. They all essentially mean the same. We're talking about a reference variables in which its value would constitute the address where the object is residing. So whatever is residing in the heap will have a global access. That means even though there is nothing left in the stack, we could still have some objects hanging around inside this heap memory, at least for some time until the garbage collector comes in and cleans them up. We'll talk about garbage collection in a moment. But this is how it works. Let's take a look at another example to bring you more clarity on this. Take a look at this. Okay, let's go line by line. We have created a new object with the keyword new, so that will create an object inside the heap memory with the values 10 and 20 because these are instance variables, and we'll have an address associated with it. In our stack memory for our main method, by the way, let's assume these instructions are residing inside a main method. There's a section dedicated for main method, and we'll have reference type defined, and it will have the information on the address where this object is residing, which is 0101. And the interpreter comes to line number 2. We have created a new reference type and we assigned this reference type to it. So we're not actually assigning the object, we're just assigning the address in which the object is residing. So here is how it gets allocated. obj2, and it will have whatever is the value inside this object 1, which is 0101. So essentially obj1 and obj2 are pointing to the same object. We're not creating a duplicate object here. Similarly, on the similar lines, we have object 3, which is holding the value which object 2 is holding, which in turn is holding the value of object. So even we'll have object 3, and that will hold the same value. So all these reference variables are holding information on the location where the object is residing. Hope that makes sense. So now the million-dollar question: why do we need to store objects in heap memory? The reason is simple. Things will get very messy, as well as it will impact the performance dramatically. What do I mean by that? Whatever are the variables residing in the stack memory are predefined types. I mean, we know exactly how much memory they're going to take upfront, right in the beginning when we compile the program. But whereas the object is JVM specific, the size of object is not certain. It can vary from JVM to JVM depending on the vendor. So it's hard to make a guess on how much memory each object would take. There are a lot of factors that come into picture when deciding the memory allocation done for an object. The type of variables, the number of variables, and we also need to consider the space it takes just to maintain the state of this object or to maintain this object itself. So it gets really tricky in here, and let's not get into it. So now that's number one reason. And number two, let's assume that there is no heap memory at all. And that also means there are no reference type. We're directly storing the object in here. Now take a look at this same example. By doing this, we're not actually pointing to single object. We have to create three different objects inside this stack, which is pretty consuming. That's a lot of memory, and each object won't consume 4 bytes or 8 bytes. It's a huge chunk of memory, and we're trying to duplicate the same data multiple times. Instead, why not just have reference type and point them to the actual object like we do? So that's reason number two. Let's take a look at one last reason why you want to store objects in heap memory. Take a look at this example. For the sake of example, let's assume there is no heap memory. So we'll have a stack and a section dedicated for main method. Again, let's assume this is residing inside the main method. We'll have an object created that will have a huge chunk of information about this object, including these variables, say 10 and 30. Now we're sending this object to this method m1. There will be a new section created for method m1, and its local variable would be the object that we sent. And let's say inside this m1 method, I updated the state of this object. Let's say object.x, I changed this value 10 to 20. Let's assume so. So now inside we'll have an object with the value 20 for x. Once we come out of this method m1, this detail will get popped out of the stack. So that means there is no information related to this method m1. That also means we don't have the details on the updated state. So when we send this object to method m2, a new section will be created, and again the value of x would be 10, not the updated value. This is clearly a problem. We're not getting the updated value, updated state of that object. Hope that makes sense. Now whereas if the object is residing in the heap, as you can guess, everywhere in all these methods m1, m2, m3, we're actually talking about the same object, and we're all pointing to the same object. If the state is updated by method m1, the rest of the methods will get the updated state. Now let's talk a little bit about garbage collection. We'll get into the details of garbage collection in our future videos, but for now, just a quick explanation on it. When it comes to primitive type or reference type, we're cleaning them up the moment we get out of that particular method. In case of objects, there has to be some way to clean them up. Otherwise, the memory of the heap will get full and we start getting some exceptions or errors like Java heap space out of memory exception. So how does JVM solve this problem? It uses a tool called garbage collection. What that does? It's pretty complicated, but in simple terms, if there are no references available in the stack, that means that particular object is eligible to be cleaned. The garbage collection process happens periodically. There is no specific time for it. It just happens periodically and takes a look at all the objects and see if it has any references left in the stack or elsewhere in the memory. If not, then it will just clean that particular object. And that way the heap memory is maintained, and it will help in not getting the memory to be full. We also have a way to configure the sizes of heap memory and the stack memory. By the way, if the stack is full, we get the stack overflow error, which I'll talk about it later. Now let's go back to our program, and I bet now you'll be able to understand the concept by yourself. Open the file, methods, and constructors. So we have, how many new keywords do you see here in this program? There are 3. That means you can straight away say that we have 3 objects created in the heap memory. In the instruction number 3, we have object 3, which is a reference type, and is actually having the same information that object 1 reference type is holding. That means the address of this particular object. Same with the object 4, it is holding whatever object obj3 reference type is holding. So essentially object 1, object 3, and object 4 are holding the same information about the same object. The reference type object 2 points to a new object altogether. Object 5 is a reference type that holds information about a new object and whose state is set based on the object 1. So that this should be 10 and 40. Hope that makes sense. See you in my next video.